Okay, now let's take another problem. This isn't really part of the document, but let's anticipate something. If x is 135, then what's the value of z? Well, 135 is between 101 and 158, and it's only 23 units from 158. The standard deviation is 57. 23 is less than half of 57, so it's going to be closer to 158 than it is to 101. So I draw it accordingly. To find the corresponding z value, well, what fraction is this of this? It's less than a half. How would you figure out the fraction? Well, what you would do is you would say, well, this distance is 23. So that's 23. And this distance here is 57. I hope that's legible. I wrote it kind of small. So if this is 23 and this is 57, and the 57 corresponds to the z distance from 0 to -1, then what would the z value be if you only moved 23? Well, it should be pretty clear that in this case you're going to have z equals 23 over 57. Now, what is 23 over 57? It's pretty close to 0.4. It's a little over 0.4. I'll make a stab just intuitively, say maybe 0.42, but don't have a lot of confidence in that. You can work it out yourself. And if I happen to luck out and get it right, don't be too impressed. Okay, so that would be the z value for this point. Now, in general, we can write down a couple of formulas, but the common sense is actually easier than remembering the formulas for most people. Although if you're good at remembering formulas, that's great, and please do. What did we do to find the x for a given z value? We took the mean and added 1.3, well, the z times your number of standard deviations. In this case, you had z equals 1.3, so that corresponds to 1.3 standard deviations. 1.3 times 0.57, which is 74. So to the mean, 158, we add the 1.3 standard deviations, which is 0.74, we get the 232. More generally, we're going to do the same thing whenever we're given the z value. We take the mean, multiply the z times the standard deviation, and add them, and that gives us the x value that corresponds to this z value. Now, algebraically, we can do the algebra, subtract the mean from both sides, divide by the standard deviation, but we haven't done a lot of algebra in this course, so I don't want to lay that on you. Although if you understand that, it's very good and useful, so please do and use it. But anyhow, what did we do here? We found the actually, let's see. I'm going to correct something I did over here. I was worried about the numbers and I didn't want to get into the signs, but that is negative 23, and this is distance of 57 here, so that the z value is actually going to be negative. Standard deviation is still 57, which is positive, but the z is in the negative direction, so, or the x is in the negative direction here, so the z value is going to have to be negative. So we'll call this displacement negative 23, divide that by the 57, and we'll get negative 0.42. Now, back to this, what did we do? We did the x value minus the mean. If we do 135 minus 158, we're going to get the negative 23. Okay, so x minus the mean tells us how far and in what direction we are from the mean. And if we divide that by the standard deviation, here's your deviation, divided by your standard deviation, gives you the z value. Okay, so I could say that, well, I used the wrong word here. This isn't deviation. It's what we call a residual. And I was going to write down I was going to say residual over standard deviation, but I'm just going to leave it like this. X minus the mean over the standard deviation, and you should understand in terms of this example exactly why that's the formula. And again, if you understand it in terms of common sense, then you don't really need the formula. But if you need a formula and good at memorizing formulas, feel free to use it.